How are you guys? Welcome back to my YouTube channel. We have this question is read as follow. These fluid mechanics and six steel pumps, under pumps, a single acting pump, reciprocating pump. There's a piston with a diameter. They've given us a diameter and the stroke length of 0.3. That is 0.5 and 0.3. The pipe diameter is 0.2. And the water is lifted vertically through a height of 13.5. If the pump speed is 50 rats per minute and the actual quantity of the water delivered is 45.2 liters per second, calculate the percentage slip in the pipe. B, the coefficient of discharge. C, the theoretical power to drive the pump. Okay. We know we are given our things. Question 1 wants what's the percentage slip. Okay, let me do this. Okay, here we have solutions. Question A wants the percentage slips. We know that the percentage slip, I can say percentage slip, I know this is equal to theoretical discharge minus actual discharge divided by theoretical discharge multiplied by 100, right? So we're supposed to, so that we'll have this in percent. This is the formula we're supposed to apply. So before I apply this formula, we will need QT. We don't have QT, right? Because here we are given only, as you can read as I've read the statement, you see we have given only the actual discharge. We've given the actual discharge. This we have, but we don't have what? The theoretical discharge. So let us start by calculating the theoretical discharge. Theoretical discharge, we know that QT, the discharge, is area multiplied by distance. In the normal pipe is area multiplied by velocity, but in the pumps is else. I'd like to say what else, but now I replace that else. You know what else? I replace this E with A. I just write A, right? Else. I don't forget because these are just write L, else, right? Now will be L, else multiplied by N over 60. LC multiplied by N over 60. This is the formula we'll use. This is area, as you know, stroke length, the length, type line, all of these things, and we know all of these. We've discussed about this, right? Number of pumping stroke, we've discussed about all of these, right? This formula we've discussed. If you return to the section 1, if you watched my video, you know this, we've discussed about this, right? This is what we need. Okay, so let us try and calculate this Q, right? This is what we need, right? So let us calculate this QT is equal to this, right? Then we can say we know this is equal to this area. We must know the area is given by pi over 4 d squared, right? The diameter is the diameter of the, must be the diameter of the piston, the diameter of the piston, right? Must be the diameter of the bore or diameter of the piston. Piston is 0.5, isn't it? It is 0.5 squared multiplied by, they wanted there to multiply by L, right? Stroke length is 0.3, would be 0.3. Number of plunger, this one, it's 1. The type of the pump is 1, it's not a double acting, right? Multiply by the rents were given, this is 50, then we'll have multiply by 50 over 60. Remember, this is 1, this is like this, it's like that. It's what we will have. So QT, when you punch your calculator, pi over 4 into 0.5 squared multiplied by 0.3 multiplied by 1 multiplied by 1 multiplied by 50 over 60. Right, you get 0.0491 cubic meters. Remember, is the quantity measured in cubic meters per second. We have this, it's in cubic meters per second, but this we have it in what? We have that in liters. So we have this in liters, we'll divide by 1000. What about actual discharge? Will be 45,2 divided by 1000. Then you will have this, it will be 0.0452 will be cubic meters per second. Right, we have the actual, then we apply the formula. Percentage slip is, we use this formula. QT is theoretical, we have 0.049 minus actual, right? 0.91 here minus actual, which is 0.0452, right? All this, divide this by the theoretical 0.0491, then percentage slip. All of this will multiply this, you'll put the brackets like this, we'll multiply this by what? By 100. Take this value and multiply it by 100. Multiply, punch this, then you multiply by 100. If you multiply by 100, so that will be in percentage, supposed to get this percentage is 7.94. Yes, is 94. Percentage 7.94%. Right. Don't forget to multiply all of these things by 1000. Isn't it? It's in percentage. Multiply this by 100. You'll have it in percentage. Right. Let's check B. What does B says? What does B says? B says we should calculate the coefficient of discharge. I hope you know the coefficient of discharge. This is from the orifice, you know, the flow of what in orifice. We have learned about this. You know that discharge must be actual discharge over theoretical discharge. Coefficient of discharge must be actual discharge over theoretical discharge. We have this, we've calculated it. Actually is this is 0.0452 over what is that? 0.0491. Right, this is what we know. We'll have 0.921. It has no SI units. Remember, this is measured in cubic meters per second, cubic meters per second. These SI units will cancel, then this will have no SI units. This is the answer. What about C? C said should calculate the power, the theoretical power. Remember, we know that power here in fluid mechanics most of the time must be calculated by rho G, must be rho G and the flow of charge, I mean the rate of charge, the flow rate multiplied by that certain depth or the certain delivery height or stuff. You know this will be G, then must be Q multiplied by what? By H, isn't it? This is the formula to calculate the power. If we have an efficiency, we'll divide by the efficiency, but we don't have an efficiency, it will be like this. Now, remember the one theoretical, this will be PT. Theoretical will be P, G, Q. Then also this Q must be T multiplied by H. If it is actual, this must be actual discharge. Since it's theoretical, will be Q of what? Of the theoretical discharge. Then we know this, it's water that is supplying there, right? They talked about is not what to quantity of water. Since it's water, the other words they tell us if they deliver water, in other words, just to tell us that but they do not, just to tell you, if they send, if we are dealing with fluid mechanics, when they say water, you must know that it's a density of 1,000. They will not write the density of what is that. You're supposed to know it. This will be 1,000. Supposed to know multiplied by 9.81 times discharge of times the theoretical discharge, which is 0.0491. You multiply this to that depth, which is H, isn't it? Let's just check which height is 13.5. Multiply this by 13.5. Multiply this by 13.5. Supposed to get that PT. When you punch that, remember it's measured in watts, right? Punch that on your calculator, must get those watts. You must obtain those watts. Will be 6, what? 6,5. Then you divide it by the answer that you get. You divide it by 1,000, so that will be in kilowatts. Then you have in kilowatts. You multiply all of these. Then after you divide by 1,000, so that will be in kilowatts. This is it, guys. Thank you guys for your time. Thank you, Lord. Thank you for watching this video. Stay tuned. Do not forget to subscribe. I'll be posting some more videos. Sharp. All the best, guys.